Dear friends, welcome to this session. In the previous sessions, in discrete random variable, we see how to find CDF using the table. So those students who don't see this video, you just see the description link. You can find what is the discrete random variable, that is part 1, part 2 videos. You can have a look on it. Now, in this session is fully going to concentrate on how to find the cumulative distribution function for the continuous random variable. Secondly, how we are going to get PDF from CDF. Okay guys, let's go into the session. Okay, so CDF, people say it as cumulative distribution function, sometime simply distribution function of a random variable. So we know whether it is continuous or discrete, the notation is going to be the same. Capital F of x, x greater than or equal to x. So this is called as a cumulative distribution function of x. So now in the continuous random variable, we are going to see the formula. It's from minus infinity to x, because x belongs to minus infinity to plus infinity. It's going to be f of x dx. So we can easily understand that when I do this integration, I'm going to get a function. I'll not get a number, because my upper limit is x. And we know all the basic properties we have seen in the discrete random variable itself. F of x lies between 0 to 1, and f of minus infinity is 0, and f of plus infinity is going to be 1. If there is a function x1 and x2 with this relation x1 is less than x2, then obviously we can see f of x1 is less than f of x2. Okay, so these are all some basics. You can refer the material. Okay, so f of x is an increasing function of x. It concludes. Okay, now let us go into the problems directly. Let us see how to find the cumulative distribution function for a given problem. Okay, so let us consider a function. X is a continuous random variable with PDF. So PDF is given now. We have to find the CDF. Sometimes using CDF, they will tell you to find the PDF value also. Both we are going to see in this session, in this problem. Okay, so my f of x is going to be split up x when it is between 0 to 1, 3 by 2 x minus 1 whole square, between 1 to 2, and then 0 otherwise. So that means my data lies between 0 to 2. If it is greater than 2, it is 0. If it is less than 0, it is 0. Okay, now what we have to find? We have to find the cumulative distribution function, and using it find. So using CDF, we have to find what? Some probability, PDF. Okay, some values. 3 by 2 less than x, 5 by 2. Okay, so we'll do 1 by 1. So remember the properties just now we seen before. We are going to solve the problem using that. Okay, so first of all, let me write probability of x less than or equal to x, that is my CDF. So we mention it as capital F of x, and the formula is minus infinity to x f of x dx. So we have to split the problem into interval by interval. Here you see what are all the intervals we have. X less than 0 we have between 0 to 1 we have, then 1 to 2, then greater than 2. So now it's our duty to analyze one by one. Okay, one by one we have to see what is happening there. Okay, so let us do the solution. So the first topic is if x less than 0. So we know that if x less than 0, the PDF is 0. Okay, the PDF is 0. Then that means my small f of x is 0. Therefore, you see, from the property we say the capital F of x is also 0 because it is the left value. Okay, now what we have to do? If x lies between 0 to 1, how to solve the problem? Okay, let's go. So from the formula, capital F of x minus infinity to x f of x dx. But you see here my lower limit is 0, so I'm going to take from 0 to x. In this 0 to x, because my limit is going to be 0 to 1, at 0 to 1 according to the question we can see the value is simply x. So I'm going to take only x here. So my function is simply x. So x into dx. X square by 2, 0 to x. So my answer is simply x square by 2. Done. So now I found the value for what? The limit, the interval 0 to 1. Now you should be careful when you go for the next limit. Now what will happen for 1 to 2? So the formula is same, but now we should be very careful when you choose the data. F of x, since my lower limit starts at 0, I'm dealing with 0 to x, f of x dx. So now what we are going to do, since my limit is going to be 1 to 2, I'll not bother about 0 to 1. And remember guys, this is cumulative distribution function. You should not go from 1 to 2. Like you have to do everything cumulatively because my starting value is 0. So first I bother about 0 to 1. When it comes for 1 to 2, then my lower limit is 1, but my upper limit is x. So let us crack. In 0 to 1 it is x dx. Now when I go here, it becomes 1 to x. Okay, now we understand. So what we are going to do now, we are going to substitute the corresponding value. So in 1 to 2, yeah, you can check the question. In 1 to 2, it's 3 by 2 x minus 1 whole square. So 3 by 2 x minus 1 whole square. So now we have to integrate and we have to find the corresponding function, guys. So this is going to be simple, x square by 2, then 3 by 2. We know the integration is x minus 1 whole cube by 3. Why? Because we know the classical formula, x power n dx. It's very simple, x power n plus 1 by n plus 1. But we use ax plus b whole power n is what? Ax plus b whole power n plus 1, a into n plus 1. So now here my a is going to be 1, so it is going to be simply x minus 1 whole cube by 3. So 3 get cancelled. Now you apply the limits. Okay. So, sorry, you apply the limits. My upper limit is x. So remember, as I said, cumulative distribution function for a PDF is always a function. You cannot get a number as an answer. Okay, when you value integrate. Okay, done. So now it's very simple. The first one is 1 by 2. When you put the upper limit, it remains the same. When you put the lower limit, 1 minus 1 is going to be 0. So it'll be having x minus 1 whole cube by 2. So we found the value for the interval 1 to 2. Next, our job is to find the value over the interval 2 or above. Okay. So when you go for 2 or above, let us see what is the status. So as given in the problem, when x greater than 2, my small f of x is again 0. But my capital F of x is 1. Why? Because we have the result capital F of x lies between 0 to 1. So my starting value when x less than 0, I say capital F of x is 0. When x greater than 2, finally it ended what? 1. Hope now you understand what is happening. So you have to write like this. And finally, we have cracked all the intervals. So we have to present the data in a nice way. So how we write? We write capital F of x. Okay, 1 by 1. The first interval is x less than 0 at 0. Between 0 to 1, and then between 1 to 2 and x greater than 2. So when x greater than 2, it is going to be 1 because of the function. And we found the other two values what we have already in from the problem. This is going to be x square by 2 is going to be 1 by 2 plus 1 by 2 x minus 1 whole cube. So this is your cumulative distribution function, guys. So now the second question what is given to us, you have to find the probability that capital P 3 by 2 less than x less than 5 by 2. This is what I have to find. So there is two ways to solve. Okay, you go with the classical way, just like 1.5, because my limit is, you see, 3 by 2 1.5 lies here. So I can say 1.5 to 2.5. So 1.5 to 2, I have to write f of x dx, and then 2 to 2.5 f of x dx. But you will not get a mark because it is mentioned using CDF. You have to solve. If nothing is mentioned, you can go like this. So I cannot do this. So let's do. I'll click. I'll delete this. So now how to find this using CDF. So we have already given the result. You can check the material. So if this is the case, it's going to be f of 5 by 2 minus f of 3 by 2. So 5 by 2 is going to be 2.5 and there's going to be 1.5. So when x greater than 2, according to our problem, it's going to be 1. When x greater than, now x is 1.5. So between 1 and 2 it lies. So it's going to be 1 by 2 plus 1 by 2. Now 3 by 2 is my x. I'm going to substitute directly. It's going to be 1.5, or you can substitute directly 3 by 2 as ever, like as a whatever it is, whatever you like. So it's going to be 3 by 2 minus 1 whole cube. Now if you simplify this using your calculator, you'll get the solution. You don't want to integrate. So this is more sophisticated than finding the PDF in a direct way. Okay, so I will write the solution directly. I left the calculation part by yourself using your calculator, guys. So the answer is 7 by 16. Hope you now got how to solve CDF or how to find CDF from PDF. And now there comes a big question. What is the guarantee that your CDF is right? You might be do some mistake. Okay, how to find that? Let us see. Let's crack this again. We'll go back. Now, how to crack this, guys? There is a classical result again, the relation between CDF and PDF. If you know the relation, then in examinations you can easily check it out. So that is, what is the relation? Capital F dash of x is always is equal to small f of x. So that means what I'm going to do when I differentiate this, let us see what I get. This part is 0 when x greater than, when x less than 0. Okay, then when I differentiate this, 2x by 2, I'll be getting x less than or equal to, lies between 0 to 1. When I differentiate this, I'll be getting 3 by 2 x minus 1 whole cube, 1 less than or equal to x less than 2. Then when I differentiate 1, it's going to be again what? 0. 0 when x greater than 2. Now you see it's your question. What is it? It is nothing but your small f of x. So if you do the problem correct, you can check the correctness of CDF by differentiating the CDF. You have to get the question PDF, then your answer is correct. So in your exams for MCQ point of view, they might be give directly CDF and they will tell you to find PDF. It's very, very easy, guys. Okay, so just now we use the problem, like we solve the problem. Okay, for that also we have to know the formula. What is the formula? The relation between PDF and CDF. Okay, just make a note on it. So probability of xi, it's going to be capital Xi minus capital Xi minus 1, where we use this and we found the solution in a very easy way. Okay, guys, done. Now you see, for an exam point of view, there is one MCQ I'm just giving you. Find the PDF given a CDF, guys. So capital F of x is given to you 1 minus 4 by x square. If x greater than 2, if x less than or equal to 2, it is going to be 0. So it's just one step solution. We know the formula. What is the formula we know? Capital F dash of x is going to be my small x. So capital F dash of x, when I differentiate, I'll be getting, so okay, this part is 0 always. If x less than or equal to 0. Okay, now tell me, guys, what is the differentiation for 4 by x square? So I have already given the formula. Okay, I'll be giving the formula again, no issues. We know that x power n differentiation is x power n minus 1 n. When it is in the denominator, it is very easy. You can remember, here it is plus n, here it will be minus n. When it goes to the denominator, here it is n minus 1, here it is n plus 1. So now you can easily write for this problem. When I differentiate, I'll be having minus 4. 1 by x square differentiation is minus 2 by x cube, guys. So it's going to be 8 by x cube. Okay, so my final answer is 8 by x cube if x greater than 2. 10, guys. So according to the result, what we say, this f dash of x is my f of x, which is my required probability density function PDF.